Question number 1. It is 32nd question of 2024 A-level paper. The transistor shown in the circuit diagram is operating in the active region. What is the approximate value of VCE? Assume that VB is 0.6. VCE means voltage drop between collector and emitter. We can get voltage at this point is 10 volts, voltage at this point is 0 volts because of it is earth point. And we can consider that IB, current through the base terminal, is a negligible current, it is a small current. Therefore, we can consider that these two resistors are series and there are same resistance values. Therefore, voltage of this point should be 5 volts because of it is according to the potential divider method. If there are same series resistors, potential of midpoint should be half of total potential difference. Then they have given potential difference between B and E is 0.6. Therefore, VE should be 0.6 less than VB. Therefore, it is 4.4 volts voltage at this point. Then we can use V equals IR for this 2 kilo ohm resistor to find the emitter current IE. Voltage difference 4.4 minus 0, 4.4. Current is IE, emitter current. Resistance 2 kilo ohm, we have to convert it to ohms, 2 into 10 to the power 3 ohms. Divide by 2, 1, divide by 2, 2.2. We can obtain 2.2 into 10 to the power minus 3 amperes. It is the emitter current. And when considering base current is negligible, we know that base current plus collector current should be equal to emitter current. Therefore, if IB is a small value, IC equals IE. Therefore, we can get that this value is equal to IC. Then we can use V equals IR for this 1 kilo ohm resistor. Voltage difference 10 minus VC equals current IC is this value 2.2 into 10 to the power minus 3. Resistance is 1 kilo ohm. We have to substitute it in ohms. 1 into 10 to the power 3 ohms. Then we can cancel out 10 to the power minus 3 and 10 to the power 3. We can subtract this value by from 10. Then we can obtain it is 7.8. Now, VCE means voltage drop between C and V. Therefore, we have to subtract VC and VE. VC is 7.8. VE is 4.4. 8 minus 4, 4. 7 minus 4, 3. Then we can obtain VCE voltage is 3.4 volts. Then second question, it is 40th question in 2024 A-level paper. Consider the logic circuit shown with 3 inputs A, B and C. What is the Boolean expression? The best represents the output F of the circuit. We can get input of this terminal is A. Input of this terminal is B bar because of there is a NOT gate before the AND gate. We know that we can obtain product by using AND gate, then A dot B bar should be output of this terminal. We can use same method. This terminal is B, this terminal is C. B dot C is the output of this terminal. We can obtain product by using AND gate. Then when using OR gate, we have to add these values A dot B bar plus B dot C. Then we can obtain, first one is the correct answer for question number 2. Then question number 3, consider the operational amplifier circuit shown in the figure with a supply voltage plus or minus 5 volts. A triangular alternate voltage V in with a peak to peak voltage is 5 volt, range from minus 2.5 volts to plus 2.5 volt is applied to the inverting input of the operational amplifier, and the fixed voltage of plus 1.5 volt is applied to the non-inverting input. which of the following best represent the variation of output voltage V out of with time? We can consider that when increasing input voltage from minus 2.5 to 1.5, input voltage is less than this 1.5. Therefore, voltage of plus terminal is a greater value. We can consider that circuit is plus saturated. Therefore, output voltage should be 5 volts up to this point. If there is a value for the saturated voltage, we have to use that value, but in this circuit, they have not given a saturated voltage. Therefore, we have to consider that this supply voltage is equal to saturated voltage, then plus saturated voltage is 5 volts. Then, after passing this point, when increasing input voltage greater than 1.5, we can observe that minus terminal has a larger voltage than plus terminal. Therefore, circuit is minus saturated. Then we can observe that for this part circuit is minus saturated. After passing this point again, plus saturated, and after passing this point 1.5 input, we can consider that it is minus saturated. Graph should be like this. Then we can obtain fourth one is the correct answer for question number 3.